Hey guys, welcome back to Better C Sharp. This time we're going to be talking about Dataflow. Dataflow is a set of classes. The Dataflow classes are a set of classes in .NET that make it easy to parallelize code. So we're going to talk about a couple of different ways to parallelize things in this video, and I'll probably name this video something like parallelization or something. Because Dataflow is not like something people search for, and I feel like the Dataflow tools just aren't like well known. It's rare that I ever see them, and it's odd because they're super easy to use and they're like very straightforward. And like once you set up one of them, you're like, oh, it makes sense, and like it just everything's so great. You guys will see when we get into it. But so Dataflow is a way to parallelize code. It acts like a pipeline. So Dataflow is made out of blocks, and you link them together, and each block points at a function, and then those things can run in parallel and pass data between each other. They're easy to set up and they're easy to throttle. So if you guys have ever had issues throttling multi-threaded code before, this will be a great thing for you. So let's talk about it. So we have this program here that we have, and instead of doing this one, we're going to do serial processor. So we have this program, and it has these steps of things that it does. And this is kind of similar to a lot of real world programs that you end up writing for backend systems, where you just want to take some data, transform it somehow, and write it somewhere else. So this particular one is going to get a list of files in a directory. Then it's going to get a vehicle out of each one of those files. And then it's going to transform each of those vehicles into a truck, double the number of doors on them, and write all of them to a single file. And we're going to look at a single threaded version of this first. So this is what it is. There's a base class here that we're using to make it easy to make different implementations that are multi-threaded without having to rewrite all the logic. We'll get into that in just a second. But anyway, this base constructor just sets up the directory we're looking for files in, our file system interface, and then an output file. And so all those get set up for us to use. And then the actual workflow of this class is we're going to get all the file names in a directory. And then for each one of them, we're going to open up a vehicle provider. We have a couple different ways to do this. Some of these are EDI files, some of them are JSON files. And then for each vehicle in those providers, we're going to turn the vehicle into a truck. Right here, you can see. And we're going to add some artificial delay in here just to make it easy to show that we're doing some work. But you can imagine this is something like await, get results from database, or whatever we need to await to do some work. And then we're going to double the number of doors on it. So we're going to double the number of doors. We're just going to write it out the console, do another delay, and then double the door count and return a new truck with that door count. And then we're going to save that truck, which just says, hey, we're saving a truck. We're going to delay for 500 milliseconds. We're going to open up our output file, go to the end of it, and then write a line. That is the JSON convert serialized object of that line. So we have an example of what's going to happen here. We can look at it real quick. We have some input files here. So some of these are EDI, some of them are JSON. And then they are going to turn into a file that is kind of like, well, I guess it's not going to open. I guess it's not there anymore. But anyway, it's going to turn into a file with a bunch of JSON trucks in it. So let's go ahead and .NET build this, and maybe we'll run it as well and just show what the actual output looks like. We probably won't run it all the way because it takes a little while to run. But yeah, so it built there. Let's go ahead and run it. So we're gonna run. Get there. This is me. This is me setting up the project to go into the GitHub account, which I'll put a link to after the video is done. So this is what it looks like in serial mode, right? Like it's just going through one at a time, making the provider, getting each one of them out of the provider, and then, transforming it into a truck, doubling the doors, and then saving it back out. And I'm just going to kill it here because this is going to take quite a while. or actually, we'll leave it running for a minute while we check out that file. So this is kind of what this is going to look like, and it's just going to keep getting more things added to it. And so this is what the output looks like. So I'm going to go ahead and kill this because it's going to take a little while to run. But now we can go and look at the second implementation of this, which is using semaphores, which this, if you're very familiar with threading at all, this is usually the way you end up seeing people do it, using semaphores. And so what ends up happening is a semaphore is basically a lock that can have multiple, or a mutex that can have multiple multiple pieces of code acquire a lock at once. So basically what you do is you make a semaphore and you tell it how many locks you can have at once. In this case, we're at 4. And then whenever you want to start a new thread, you say, hey, I gotta wait until I can get a lock. And then as soon as you get that lock, you start up by adding a new task to a list or whatever. And then when you're done with your task, you just release the lock. And so what this will do is this is the same basic logic we had from the serial processor. So you can kind of see it's very similar, but we just sprinkled multi-threading on top, right? So we've got the semaphore, and we've got waiting for a lock, and we're making tasks out of it. An important part here is the finally, because if anything goes wrong in any of this code, and you somehow, don't end up releasing the semaphore, then you can end up with a deadlock, because you're going to have multiple things waiting on a lock, and if you have 4 of them here in this case that don't ever release, then they're never going to be able to get that lock. So that is one thing that can happen. So let's go ahead and use this one real quick and show what that looks like. So we're going to go ahead and say Semaphore Parallel Processor, and we'll run this. And what you'll notice is that we end up with it's going to run 4 at a time, right? So it's doing one file, but it's doing like 4 at a time-ish. Maybe 3, I don't know. I think it's 4. Yeah, it looks like 4. So it's doing 4 at a time. It's doing them a lot faster. But what you'll notice about the code, and, well, let's talk about what's actually happening first. First of all, we're still only doing 1 file at a time, which is annoying. And we could fix that, but, like, not easily with the way the code is set up, right? And the other thing is, one thread does the entire workflow, right? So you can't start, if you have 4 trucks going, you can't start the next truck until one of those trucks is completely done, right? Until all 3 of these methods have run and been awaited. And so that's not like as parallel as you can get, because in theory, you could be running, like as soon as one truck is done getting transformed, you should be able to start transforming another truck. So really, you could wrap all 3 of these functions with semaphores, but like it's just that gets painful. And so we'll talk about the best way to do this now, which is a Dataflow parallel processor. So what I've got here is we've got an implementation here, and the way Dataflow blocks work is you have these classes called Dataflow blocks, and they each target a function, and then you can link these blocks together to form a pipeline. And then you can have input that goes into the first block, and then the first block represents some function that runs. And then when it's done, it passes the output to the next block. And what's interesting is, like, as soon as, like, you got 4 trucks being able to be transformed, and you got 4 doors being able to be doubled. As soon as one truck moves to the doubling stage, the next truck gets started over here, and the next doubler, like when one of them moves from here, then the next one can go ahead and start. You don't have to wait for one truck to make it through all 3 stages, if that makes sense. So anyway, I've got some code here. I'm going to pull over. The way this works is you end up getting some blocks. So let's go ahead and talk about this. So the first one might be something like we're going to take in a string that points to a directory, like just like if we go back over here to our, let's go to our serial processor. So we're going to take in a string, right? And and this string is actually going to be directory right here. So we're going to take in a string representing a directory, and we're going to get back file names. And so that's a one-to-many transformation. So what you need for this is, we'll say a list files block. And the type you need is a transform many block. And we're going to go from one string to many strings, right? And the argument that you give to this can be like anything that's like a function. So anything like a delegate. You could do a delegate, you could do a lambda, you could do a func object, you could do a function name here. We're going to do a function name. So we'll do file system.get file names. And so that's our function name, right? So this is going to pass in a string to get file names, and it's going to get back many file names from this method here. So that's exactly what we would expect. And then the next thing we need is to get vehicles out of each one of these files. So next one is going to be get vehicles block. I've got this code over here on the side. But this is also going to be a transform many. We're going to take in one file name. So we got a bunch of file names out of a directory. We're going to take in one file name and give back many vehicles. So we're going to say new transform many block, right? And we're going to go from a string, and we're going to give back vehicle, right? And so let's talk about this for a second. So what we would end up doing here is we would take something like some kind of input string, right? And we would do something like, if we look at our other serial processor, we call get vehicle provider, and then we return get vehicles. So what this would actually look like is something like get vehicle provider of the input, and then dot get vehicles. But this is problematic because get vehicle provider returns something that is disposable. You guys might not realize that, but vehicle provider implements disposable. So we need to dispose of that. So we don't want to do that like a lambda here. So we want to make a function for this. And so I've got this already written. We're just going to copy it. Yep. So we're going to give back a bunch of vehicles. We're going to take in a string, just like this says in here, right? We're taking in a string and giving back many vehicles because we have a transform many block. And then we're going to get a vehicle provider for the file name, and then we're going to yield return each vehicle in the vehicle repository. So in here, we're just going to call get vehicles. Okay? Simple enough so far, right? The next thing we're going to want to do is transform those vehicles into trucks, just like we did for our other serial processor. So then the next thing was transforming them into trucks. So we're going to go ahead and do that as well. So we're going to save our transform block, which is kind of punny because we're going to make a transform block. So this is not a transform mini block. This is a transform block. And it's going to take one vehicle and give back one truck. So that's why it's not a transform mini block. So it's one vehicle to one truck. So this is going to call transform, right? Transform async. So when we look at the definition of that, it's the same thing we were calling earlier. So we're going to write line, delay, and then return a new truck with all the same properties. And then the next one is going to be, we're going to double the doors, just like in the serial implementation. So double block, which is another transform block. So we're going to take in a truck and give back another truck with its doors doubled. So this will be double doors async. And then for the last thing, we want to save them. So we'll say save block equals new action block. So this one doesn't give anything back. It just performs some action over a truck. So we're going to take in a truck, and we're just going to call save truck async. And so these are like our functions that we want to have parallel, and these describe what comes into them and back out of them. And now we have to link them all together. But to do that, we also want to do something. We need to set up some options for that. So we have a data link options here, data flow link options, and basically we just want to set propagate completion to true, and we'll deal with that in just a second. So let's go ahead and link all these blocks together. So the way you do that is you do list files block link to, and we're going to say get vehicles block, and we're going to give it link options. And then we're going to do the same thing for each one down the list. So get vehicles block.link to transform block with the link options, and then transform block dot link to, and then double block with the link options. And then finally, double block is going to go to the save block with link options. Okay, and then to kick all this stuff off, what you have to do is send in the input to the very first block. So list files block is going to, if you're doing this non-async, you would do post, and it will return false if you can't post because there's like a limit. We'll talk about that in a minute. But we're doing it in an async way. So you do send async, and then what we want to send in is the directory. So we want to await this. So we have to make this async. And so after that, now we've sent in the directory, so everything's going to start doing its thing, like behind the scenes. And so the next thing we want to do is say we're done sending directories. So what we do is call complete. And so this will say, hey, list files block has done its job once it's finished propagating the first directory through. And so once that's done, because we've linked these all with propagate completion to true, once everything's done in the list files block, it's going to say, hey, I'm complete. And it's going to notify the get vehicles block. And then once those are all done, they're going to notify the transform block and so on to the very end. So that's why we needed the propagate completion to be true. And then at the very end, we just await the very last block. So save block is our last block, and it has a completion task. So we just await that. Okay. So there is that. Let's see. We should be able to run this, I think. Let's go back out to our program and use our Dataflow parallel processor. And let's go ahead and run it. And I think what you're going to notice is it's probably still going to just do one at a time, but in parallel. Right now, oh no, it's not really doing things in a multi-threaded way. Like, there's only kind of one thread per thing, I think, going on here. I don't know exactly what the initial options are, but what we want to do now is make this actually do things very parallel. So what we're going to do then is we're going to cancel it. We're going to go back in here, and we're going to set up some more options. So we want to get some settings here, which is actually needs to be called options because it's an options. And so our max degree of parallelism, we want to make it like 4 or something. Options. Okay. And so now if we run this, what you're going to notice is it's going to go a lot faster, and it's going to do many more things at once. So you can see it's like doing chunks at a time, right? And another thing you're going to notice is that it's also doing more than one file at once, because we like passed in directory and it found 4 files, and so it was like, hey, we can do more than one file at once. Let's pass them all down to the next block. And then the next block is like, hey, we have all these file names, but we're getting all these vehicles out of them, and we're doing it many times at once. And like, it's just parallel across the whole board. Like, the entire pipeline is parallel. And so it's like if you had set up like a thread for every single one of those files, and then within those files, every single one of those vehicles. Like, it's massively parallel down the entire pipeline, and the setup for that was super easy, right? We basically described some functions here with these blocks. We linked them together in a certain order. We set up their options, and then we sent in the argument to the first function. And if you have multiple directories, you could do like for each directory and some list of directories and send them in, and then you could do that. So you're not limited to just one send here either. But like, this is super powerful in my opinion. And another thing I want to talk about here is actually another block type called the batch block. A lot of times what I end up doing is like, I'll be trying to save a bunch of things to SQL. excuse me, and you don't want to just send one thing to SQL at once. Like that's super inefficient and super slow. So a lot of times I'll use like SQL bulk copy, but you don't want to do SQL bulk copy on just one truck, right? You want to do it on many trucks. So there is a batch block. So if we do batch block equals new batch block of truck, and then we're going to say 10. We want 10 trucks. Then we can go ahead and link double block to the batch block, and then we can link batch block to the save block. But what you're going to find out here is the save block doesn't quite make sense here, because the batch block is like, hey, I'm waiting until I have 10 trucks, and then I'm going to send them to the next part of the pipeline. But 10 trucks doesn't fit in a single truck, which is what we're saying here, right? Like, we're saying we only want one truck. So really, we want an I enumerable of trucks. And that's not going to work with our save truck async, because this only takes in one truck. So instead of breaking that, let's just grab this, and we'll come back here, and we will create a new method called save trucks. And we'll say it takes in an I enumerable, and we'll say for each bar truck and trucks. And this needs to be trucks. Then we're going to save the truck. And so now what we'll end up doing, in fact, let's change this a little bit. We'll say saving trucks.count trucks, right? And then we'll go back up here, and instead of calling save truck, we'll call save trucks. And so now what we're going to have is all these things are going to run in parallel except until they get to the batch. And then the batch is going to be like, oh, I can't do anything yet until I have 10 trucks. And then you'll notice once it's got 10 trucks, it'll pass them down, and then we'll save them all at once. And if you were doing like a SQL bulk copy, then you could do like, you know, if you've got millions of these records, you could be like, whoa, wait, I don't want to save until I've got 1,000 records or whatever. So this is how you can bulk copy stuff like inside the pipeline, or bulk do anything really. Yeah, so this is a great way to parallelize things. I hope this makes a bunch of sense. And like you can throttle this really easily. We didn't really talk about exception handling here. Maybe I'll save that for a different video, but that's a very, very good topic for this as well. Exception handling in any kind of parallelization is a difficult thing. So I think I'll make another video for that. You can see here, like with 10 threads, like it's just way, way faster, right? And you also notice like at the end, it just saves 6 because it couldn't get 10, but we had sent completion down. And so it like got there. So it was like, hey, it's already done. There's no more to come. We've only got 6. We just have to send them. All right, so I hope that helps you guys out. I hope you guys will use this to speed up things in massive ways. And I hope it helps. If you guys have any questions about this, feel free to leave them in the comment section. If this helps you out to make some stuff super parallel, give me a like. Maybe subscribe if you like what I'm doing here. And yeah, thanks for watching. I'll see you guys next time.